Good evening. Today I am going to explain about linear variable differential transformer. So, as the name suggests, many people get confused that it is a transformer, but actually it is a transducer, not a transformer, because its working principle is same as the transformer, that is mutual induction principle. And output across its secondary coil is in the form of differential voltage. That's why it is named as a linear variable differential transformer. So it is categorized as an inductive transducer used to measure the speed or position of an object. So generally most inductive sensors work on the principle of a transformer. Let's see, discuss the complete concepts of LVD in detail. Okay, what is Lvdt? That is a linear variable differential transformer. Is an electromechanical type inductive transducer that converts rectilinear displacement into an AC electrical signal. So since Lvdt is a secondary transducer, physical quantities such as force, weight, tension, pressure, etc. are the first converted into displacement by a primary transducer, and then Lvdt is used to measure it in terms of the corresponding electrical signal. So since Lvdt is an AC control device, there is no electronic component inside it. It is the most widely used inductive sensor due to its high accuracy level. So its electrical output is obtained because of the difference in secondary voltages, hence it is called as a differential transformer. Okay, let us see about Lvdt construction. Lvdt consists of one primary winding P and two secondary windings S1 and S2. So mounted on a cylindrical former, both the secondary windings S1 and S2 has an equal number of turns, and this is placed identically on either side of the primary winding. So in such a way that the net output will be the difference of the voltage of both secondary windings. So there is a movable soft iron core placed inside the former. So hydrogen annealing is done on the iron core to reduce harmonics and the residual voltage of the core and thus provides high sensitivity. So the movable core also is laminated in order to reduce the eddy current losses. So the displacement to be measured is attached to the movable soft iron core. So Lvdt is placed inside the stainless steel housing because it will provide electrostatic and electromagnetic shielding. So let's see how the Lvdt will works. What is the working principle of the Lvdt? So the working principle of Lvdt is based on the mutual induction principle. When AC excitation of 5 to 15 volts at a frequency of 50 to 400 Hz is applied to the primary winding, then the magnetic field is produced. The magnetic field induces a mutual current in the secondary windings. Due to this, the induced voltage in secondary windings, that is S1 and S2, or E1 and E2 respectively. Since both the secondary windings are connected in series position, the net output voltage will be the difference of both induced voltages, that is E1 and E2 in secondary windings. Hence the differential output of Lvdt will be E0 is equal to E1 minus E2, or V0 is equal to V1 minus V2. So now according to the position of the core, there are three cases that arises. Let's see what are the three cases. So when the core of Lvdt moves towards secondary windings S1, then in this case the flux linkage with S1 will be more as compared to S2. This means the EMF induces in S1 will be more than the induced EMF in S2. Hence E1 is, that is V1 is greater than V2, and net differential output voltage V0 is equal to V1 minus V2 will be positive. This means the output voltage E0 will be in phase with the primary voltage. And second case is when the core is at the null position, then the flux linkage with both the secondary windings will be the same, so that the induced EMF, that is V1 and V2 in both the windings will be same. So hence the net differential output voltage V0 is equal to V1 minus V2 will be 0. So it shows the node displacement of the core. And the third case is when the core of Lvdt moves towards the secondary windings, that is S2, then in the case the flux linkage with the S2 will be more as compared to S1. It means the EMF induced in S2 will be more than the induced EMF in S1. So hence V2 is greater than V1 and net differential output voltage V0 is equal to V1 minus V2 will be negative. It means the output voltage E0 will be in phase opposition, that is 180 degrees out of phase with the primary voltage. So from all the three cases, the direction of the movement of an object can be identified with the help of the differential output voltage of Lvdt. If the output voltage V0 is positive, then that means the object is moving towards the left to from the null position. Similarly, if the output voltage V0 is negative, then this means the object is moving towards the right of the null position. So the amount of magnitude of displacement is proportional to the differential output of the Lvdt. The more the output voltage, the more will be the displacement of the object. So that if we take the core out of the former, then the net differential of the output of Lvdt will be 0. So in fact, corresponding to both the cases, whether the core is moving either left or right to the null position, then the output voltage will be increased linearly up to 5 mm from the null position, and after 5 mm output V0 will be non-linear. Okay, so what are the advantages of using this Lvdt, that is linear differential transducer? It is smooth and a wide range of operation. This Lvdt has a wide range of measurement of displacement. It can be measured displacement ranging from 1.25 mm to 250 mm, and it has high sensitivity and it has low hysteresis losses, it has low friction losses, it has rugged operation and low power consumption. So these are the, and also direct conversion to electrical. We can convert the different parameters to electrical signal, and it has a fast dynamic response also. These are the main advantages of this Lvdt. It has a few disadvantages. Since Lvdt is an inductive transducer, so it is sensitive to stray magnetic field. Hence an extra setup is required to protect it from stray magnetic fields, and also since it is an electromagnetic device, it is also gets affected by vibrations and temperature variations.